Hi students, today I am going to discuss about the amines, that is called nitro compounds. In this lesson, you have to concentrate mainly the classifications, then the nomenclatures, preparations and the properties, the chemical properties of amines. Then the product identification, compound identification type question, then chemical test, distinguishing the chemical test. In this topic you have to more concentration, give the more concentration. Hi students, see I am going to discuss the amines, that is nitro compounds. The previous year question paper 2015 to 2020 question and answer. So in this lesson you have to mainly concentrate the IUPAC name, nomenclatures, the organic compounds like amines, then the reasoning type questions, after that the convert type questions, there is a single step conversion. Then the product identification, already we seen the product identification, compound identification. Similarly here also the product identification is there, compound identification is there, then the distinguishing of the chemical test, then finally the order of the reactivity like solubility, acidic strength, basic strength, like that. That is the arrangements of the order of increasing order or decreasing order, whatever it is. This is just like order of the reactivity of this type of question. Now we will see one by one the question wise. The first question is arrange the following. First one, the CH3 thrice N, C2H5OH, C2H5NH2, increasing order of the boiling point. The tertiary amine, primary amine and alcohol is given. You have to arrange the increasing order of the boiling points. Then the tertiary amine, primary amine and secondary amine is given here. You have to arrange the increasing order of the base strength. Then this question, this is decreasing order of the solubility. Decreasing order of the solubility. Like here also the primary amine, secondary amine and tertiary amine is given here. The first you have to write the increasing order of the boiling point. So the increasing order of the boiling point, the tertiary amine, first write the tertiary amine, that is CH3 thrice N, then second is primary amine. Here next is what? Tertiary amine, then secondary amine, then primary amine. Here the primary amine is given, so that just write C2H5NH2, after that what? Alcohol, ethanol. So this is the increasing order of the boiling point. Then the second is given here, the first one, then the second one. Here the increasing order of the base strength in gas phase. So here also the primary tertiary amine first, then is less than second, there is a secondary amine. Secondary amine is what? C2H5 twice NH and less than primary amine, that is C2H5NH2. So this is the increasing order of the base strength in gas phase. Then finally the decreasing order of the solubility. So decreasing order of the solubility, here also the primary amine, the secondary amine and the tertiary amine is given. So first decreasing order means use first primary amine CH3 NH2. So here decreasing order, then secondary amine CH3 twice NH, then CH3 thrice N. So this is the arrangements of the following questions. The first one, the increasing order of the boiling points. Second one, increasing order of the base and gas phase. Third one is decreasing order of the solubility. So this is the answer. The next is write the IUPAC name of the following. The 4 names are given here. The 4 structure. I have to write the name. The first one is CH3N, CH3, CH2, CH2, CH3. So here you have to give the numbering like this: 1, 2, 3. The first position having the tertiary amine. So that 2 methyl groups are present, so that N tertiary amine, that is why I am using N, N, dimethyl, N, dimethyl, 3, word root is 3, so that first position is amine, so that dimethyl propan 1 amine. So NN dimethyl propan 1 amine, the first name. Then the second is benzene ring attached to the NH and C2H5. Here the secondary amine, that's why I am using here N. Then ethyl, N-ethyl, this totally called benzenamine, N-ethyl benzenamine, N-ethyl benzenamine. Then the third, CH3, CH2 twice NCH3. So you can write this formula, that is C2H5 N C2H5 then CH3. So this is the arrangement, structural arrangement. Now one is here, 2 ethyl groups are present. So one is considered as a word root and 1 methyl, 1 ethyl. So that the tertiary amine. N ethyl, in that alphabetical order you have to use ethyl first. N ethyl, then N methyl, this one methyl group, this one ethyl group, this is ethanamine. N ethyl, N methyl, ethanamine. N ethyl, N methyl, ethanamine. Then look at this, the third one. The third one is here, just you can write it like this: CH3 NH CH CH3 CH3. Okay. So here the first question you can tell this this is 1 means this is 2, this is 3. This is the word root. Okay, 1, 2, 3. So second position having amine. So one is methyl. So that this is a secondary amine. So N methyl, this group, and propan 2 amine. So N methyl propan 2 amine. So this is the IUPAC name of this following. Just take the answer. This is the reasoning type question. The give reason for the following question. The first question is, aniline gets colored on standing in air for a long time. Why? Then the second question is, secondary amine is more basic than primary and the tertiary amine is aqueous solution. That is an aqueous solution. Why? Give reason. Then third question is, amine is more basic than cyclohexylamine. Why? Then acetylation of aniline reduce its activation effect. Then fifth question, although the NH2 group amine is ortho or para directing group, yet aniline on nitration gives a significant amount of meta-nitroaniline. Why? Give this reason. The first question answer is, aniline gets colored on standing in air for long time means it gets oxidized. Aniline get oxidized, react with air. What happens? It undergoes oxidation process. That is why the compound develops a color. So in primary level, in beginning level, there is no color. The aniline is a colorless compound. Once react with air, what happens mean it develops like brown in color. Okay, that solution look like brown in color. It means they get oxidizes. So the reason is what? Aniline gets oxidized. That is why on standing in air for long time, it develops the color. The reason is oxidation. Then secondary amine is more basic than the primary and the tertiary amine. Here it is because the secondary amine is more stable than the primary and the tertiary amine. So because of the plus I effect, due to plus I effect and the solvation effect. The reason is you have to write plus I effect and the solvation effect. Then the third question, amine is more basic than cyclohexylamine. See here, the cyclohexylamine, the C6H5, this is the electron withdrawing nature. So electron withdrawing group decrease the electron density on the nitrogen in aniline, but cyclohexyl group, look at the cyclohexyl group, electron is releasing. In aniline, what happens? Usually electron withdrawing nature nitrogen in aniline, but the cyclohexylamine is electron releasing. So increase the electron density on the nitrogen, making more basic. So this is the reason amine is the more basic than cyclohexylamine. Then that the fourth question, the acetylation of aniline reduces its activation effect. Why? Here you know that the acetylation group CH3COCl, usually that is called acetyl chloride. In that the CH3C double bond O groups the electron withdrawing group. So the result, the electron densities decreases on nitrogen atom. Aniline reduces the activation energy. There is activation effect, not energy, activation effect. I repeat this answer. The CH3C double bond O groups electron withdrawing, as a result decrease electron density on the nitrogen atom of aniline. That is why they reduces the activation effect. Then although NH2 group ortho or para directing group at aniline on nitration gives a significant amount of meta nitration. See, there is meta nitro aniline. Why? Here the nitration occurs in acidic medium. In acidic medium, aniline gets protonated. So the answer is aniline gets protonated. In acidic medium, the aniline gets protonated. This is the answer. So that mainly you can write it, that is they forms like a benzene ring with the NH3. I will write to this. That is called anilinium ion. The formation of the anilinium ion. This is the reason. The anilinium ion. So NH3 group is meta directing because of the electron withdrawing nature. So this is the reason. See, write the structures of the compounds A, B and C in the following reaction. First, the acetic acid react with ammonia on heating to give A. That A gives the A react with the bromine water in the alcoholic solution of potassium, aqueous solution of the potassium hydroxide gives B. Then this B react with the chloroform, then plus alcoholic potassium hydroxide to give C. See what is the A, B, C in that reaction. Simply here the NH, this gives A will be, this react with NH3 on heating, you will get acetamide CH3CONH2. Here the one of the hydrogen and it goes, that is removal of the water molecule. So we will get acetamide CH3CONH2. Then this A react with, this is A, compound A. This A react with the bromine water and the aqueous solution of the potassium hydroxide. So aqueous solution of the potassium hydroxide gives that CH3 NH2. This is gives B. This is called B. This is methanamine. This methanamine react with CHCl3 and the alcoholic potassium hydroxide. So to give the acetonitrile, CH3 C triple bond N. So this gives acetonitrile C. So A is amide, B is amine, and C is nitrile compound. This is the answer for this reaction. See next, write the structures of A, B, C in the following reaction. The C6H5CONH2 gives react bromine water, aqueous solution of potassium hydroxide gives A. Then this A react with sodium nitride and HCl. The temperature ranges 0 to 5 degrees Celsius gives B. This B react with potassium iodide to give C. Then similarly, the methyl chloride react with potassium cyanide to gives A, and A react with lithium aluminum hydride to gives B. The B react with chloroform and alcoholic potassium hydroxide gives C. Now the first reaction, this react with the benzenamide react with this to gives aniline, CO NH2 react with bromine water and aqueous solution of potassium hydroxide to gives aniline, that is C6H5NH2. Then this C6H5NH2 reacts with the sodium nitride Sandmeyer reaction and HCl. See here the nitrous acid is taken. HNO2 is a nitrous oxide. The nitrous acid is readily oxidized. That's why we have to use the sodium nitride with the HCl to use what? HNO2, that is nitrous acid. Then the temperature range is very important, that is 0 to 5 degrees Celsius to give diazonium chloride. So that benzene diazonium chloride C6H5N2Cl. Okay, N2Cl minus, N2 plus and Cl minus, benzene diazonium chloride. This benzene diazonium chloride reacts with the potassium iodide. What happens mean KCl will goes out, then nitrogen will goes out. So we will get C6H5 iodobenzene and nitrogen. Okay. So this is the first reaction sequence. Then the second reaction, CH3Cl react with KCl. So what happens? KCl will remove away, minus of KCl to form CH3CN. This is methyl cyanide. Methyl cyanide is formed. This methyl cyanide further reacts with lithium aluminum hydride. So what happens to get CH3, CH2, then CH2, CH3, NH2, aniline, sorry, ethanamine. Okay, this ethanamine reacts with that CHCl3 plus alcoholic KOH to gives ethanamine C2H5, that is CH3CH2CN. So ethanamine we will get. The first reaction sequence, the A is what? Aniline. Then the B is what? Benzene diazonium chloride. C is iodobenzene. Then the second reaction, A is methyl methyl cyanide. Then B is, this is A. This reaction, this is A. This is B. This is B. Ethanamine. Then ethyl cyanide. C is ethyl cyanide. Here C is iodobenzene. So this is the reaction. In this type of question, It's mostly in this type of questions will often come. Okay, just practices this type of question. See, the next question is, write the chemical equation involved in the following. Name reaction. The first is Hofmann bromide degradation reaction. Second one is carbylamine reaction. Third one is the Cabriole Thalamide synthesis. The first Hofmann bromide degradation reaction is the benzenamide react with the bromine water and the presence of 4 moles of potassium hydroxide solution. On heating, you will get aniline. Then potassium carbonate, potassium bromide and water molecule. Here already we seen this reaction before the question, that is compound types of question, identification of the A, B, C type question. Then the second is carbylamine reaction. The ethylamine react with the chloroform in the presence of potassium hydroxide solution to form that ethyl nitro, that is isocyanate amine, that is called ethyl cyanide and the potassium chloride, then water molecule. So this is the carbylamine reaction. Next, Cabriole Thalamide synthesis. This Cabriole Thalamide synthesis, the thalamide react with the potassium hydroxide solution to form the potassium salt of thalamide. This is the potassium salt of thalamide. Then the ethyl chloride is formed. Again, this react with that alkyl halide, any alkyl halide, to form this is the N-ethyl thalamide. The N-ethyl thalamide. Then the N-ethyl thalamide react with the sodium hydroxide, aqueous solution of the sodium hydroxide undergoes hydrolysis process to form the sodium salt of phthalic acid. Then the primary amine is formed. Sodium salt of phthalic acid and the primary amine is formed. Okay. So this is the name reactions of this reaction. See, how will you convert the following conversion? First, nitrobenzene to aniline. Second is ethanoic acid, that is acetic acid to methenamine. Third is aniline into N-phenyl ethanamide. First, the nitrobenzene to aniline. The nitrobenzene undergoes a reduction process, that is in the presence of tin and HCl to convert aniline. Then the acetic acid, that is ethanoic acid. Ethanoic acid treatment with ammonia and heating, it gives ethanamide. The ethanamide further on treatment with bromine water and aqueous solution of potassium hydroxide to gives methenamine. So this is the conversion of the ethanoic acid to methenamine. Then the last one, aniline to N-phenyl ethanamide. Aniline treatment with the acetyl chloride to form N-phenyl ethanamide. This is the single step conversion. See, the distinguish between the following pairs the suitable chemical test. First, aniline and the ethylamine. Second is aniline to benzylamine. Then methylamine and dimethylamine. Aniline and N-methyl aniline. See, the first aniline and ethyl amine. Here, the aniline and adding the benzene diazonium chloride, aniline forms yellow azo dye, but the ethylamine does not form. Aniline forms yellow azo dye, azo compound, but ethylamine does not form. Then aniline and benzylamine. The aniline and benzylamine means here and adding the benzene diazonium chloride, aniline forms yellow azo dye, but benzylamine does not form yellow azo dye. So this is the both questions having the same answer. Aniline forms with the react with the benzene diazonium chloride to form yellow azo dye, but ethylamine and benzylamine does not form. That is the benzene diazonium chloride. Then methylamine and dimethylamine. Methylamine and the dimethylamine. Here, methylamine adding of the chloroform and the potassium hydroxide solution, methylamine will give the offensive smell, but dimethylamine does not react with this compound. Then aniline and N-methyl aniline. Here the same answer. The chloroform react with the potassium hydroxide and aniline to form that offensive smell, that foul smelling compound, but N-methyl aniline does not give the characteristic smell. Okay, this is the answer for the chemical test. So next question is complete the following reaction. Benzene diazonium chloride react with aniline in the presence of base. What is the product? And the benzene diazonium chloride react with ethanol. What is the product here? The first question, the coupling reaction. Here the benzene diazonium chloride react with aniline to gives, in the presence of base, to gives para-amino benzene. So this is the para-amino benzene. This is called para-amino benzene. Then the second is benzene diazonium chloride react with ethanol. C6H5N2Cl, N2 plus Cl minus react with ethanol to gives benzene, that is C6H6 and N2 plus HCl plus acetaldehyde. So this is the answer. See, next is write the structures of the main products when benzene diazonium chloride react with the following reagent. See, copper cyanide and the copper and hydrogen fluoride. First question answer is when benzene diazonium chloride N2 plus Cl minus N. This is benzene diazonium chloride react with what here CuCN and the potassium cyanide, means you will get benzonitrile. Will get the benzonitrile. Then the second is Cu with HCl. That is also one of the Sandmeyer second step. The benzene diazonium chloride react with copper in the presence of the HCl to form chlorobenzene and the nitrogen gas. Here also the nitrogen gas is evolved. Okay, this is the answer. Hello students. See, today we were seeing so many things. There's conversion, the product identifications, then the name reaction. So many things we were seeing in this chapter. Just go through this video and prepare well your examination.